First, we will discuss common mistakes that you could make in CAD models. One of the common mistakes is seen in the modeling methodology. This is where you might have poor featuring sequencing, or an over-constrained sketch, or unstable reference selection. When there is poor feature sequencing, you might cause downstream rebuild failures, or dependencies that break when there is some change in the design. It's worth noting here that overcomplicating feature trees is difficult to modify. When looking at constraining your geometry, often there may occur some redundant or conflicting dimensions or relations. The sketches that are fully defined may be too rigid for design changes. If you change one dimension, another one breaks or is not valid anymore. Hard-coded values used instead of equations or global parameters make design changes time-consuming and bound to break. It is important then to avoid unstable reference selections as well. With design changes, your reference faces or edges may disappear. You should avoid using temporary geometry as a permanent parameter. Further, reference chaining could result in cascading failures. The best practice that you could follow to solve mistakes in modeling methodology includes using strategic modeling approaches. These are approaches like the top-down design methodology, where you have some master sketches controlling multiple features, or skeleton models that define key reference geometry. A layout-driven design is another top-down design methodology that ensures proper fit and function. You could use parametric design principles, having global variables for critical dimensions, or equations relating dependent parameters. A good parametric design method is using design tables for configurable components. For your feature organization strategy, use logical feature grouping, for instance with core, detail, and manufacturing features. Use descriptive naming conventions for your features, and use suppression states depending on whether you have to perform an analysis and whether you're visualizing the model. The second most common mistake lies with your design intent. You may have a lack of parametric relationships, with missing links between related dimensions, hard-coded values instead of equations or derived values, or you missed using configurations or design tables for part families that you utilized. There might be an ineffective assembly constraints where you over-constrained assembly with redundant mates. Maybe you have poor constraint sequencing, which causes the model to lock in place, or you specify rigid mates where flexible connections are needed. The way to remedy this is to utilize robust construction techniques. Firstly, use a stable reference selection hierarchy. Set default planes and axes as primary references. Construct reference geometry for complex features. Avoid referencing temporary or derived geometry. Secondly, use best practices for sketching like fully defined and not over-constrained sketches, carefully selected external references, and standard sketch layouts for common features. And for your assembly methodology, let the project guide you on using either a bottom-up or a top-down approach. Use patterns for repeated elements, and use simplified representations for large assemblies. The third most common CAD mistake lies in the management of CAD data. Having inconsistent file organization with scattered reference files, no clear naming convention for parts and assemblies, and poor revision control and tracking. Maybe there are some issues with hardware utilization, where you are excessive in the details you use to add to the model, or you're not utilizing the built-in featuring tool, which causes slow rebuild times, or you work with large assemblies without simplifying representation. Probably the most common difficulty with CAD is having collaboration barriers, where you and your team have incompatible workflow processes, difficulty communicating design intent with each other, or not having a standard for shared design libraries. The best practice for data management problems is introducing a collaborative design environment. Set up a standardized component library with centralized management of standard parts, template parts already containing the required best practices and design reuse strategy for common components. Make use of the integrated documentation that you don't have to have some SOP open along with the designs. You can embed annotations for design intent. You can use model-based definitions to use in manufacturing, and you can have drawings automatically generated from your 3D models. Further, your data management and version control best practices should include clear file naming and numbering systems, formal procedures for checking shared entities out and back in, to ensure that you don't corrupt or override changes, and also utilize lightweight representations for design reviews.